Hello friends, I am RM Guru working as Assistant Professor in Sharad Institute of Technology, College of Engineering. This is module number 5. In the previous lecture we have seen how to make use of theodolite, how to read the angle by making use of theodolite and different terms in the theodolite survey. So today we are going to see what is closing error and how to distribute the closing error and how to prepare what are the content of Gales table. So friends, in this slide we are going to see what are the methods of traversing. There are 3 methods of traversing, namely included angle method, deflection angle method, fast angle or magnetic bearing method. So we will consider the traverse in a clockwise direction as it is convenient to measure horizontal angle by theodolite. Included angle method. This method is most suitable for closed traverse. The traverse may be taken in clockwise or anti-clockwise order. Generally, a closed traverse is taken in the anti-clockwise direction. In this method, bearing of line is taken. After this, the included angles of the traverse are measured. This angle may be interior or exterior. Please refer the figure 9.16. The theodolite is set up at station A. The plate bubble is leveled. Vernier A is set to 0 degree and vernier B is set to 180 degree. And then the upper clamp is fixed. The telescope is oriented along the north line with the help of tubular compass fitted to the A frame of the instrument. Then the magnetic bearing of line AB is measured. Again, vernier A is set at 0 and upper clamp is kept fixed. The lower clamp is loosened and the ranging rod at E is bisected. Now the clamp is tightened and the upper one is opened. By turning the telescope clockwise, the ranging rod at B is bisected. The reading on the vernier are noted and the angle A is obtained in this fashion. The phase of the instrument is changed and angle A is measured once more. The mean of 2 observations gives the correct value of angle. Similarly, the other angles are measured by centering the theodolite at B, C, D and E. The arithmetic check is applied as follows, that is 2n minus 4 into 90 degree should be equal to sum of interior angle, where n represents the number of sides. If there is any discrepancy, the error is distributed among the angles. Then for plotting the traverse, latitude and departure of the traverse legs are calculated. The interior details are marked by applying the plane table or transit and tape method, which will be discussed later. Then the second method of traversing is deflection angle method. This method is suitable for open traverse and is mostly employed in the survey of rivers, coastline, roads, railway, etc. Suppose an open traverse starts from station A. The following procedure is adopted. So refer the figure 9.17, where AB, BC, CD and DE, these are the survey lines, and phi 1, phi 2 and phi 3, these are the angles called deflection angles. And there is a river. Then the theodolite is set up at A and then centered and labeled. After this, the bearing of line AB is measured in the usual manner. Then the theodolite is shifted and centered over the point B. The plate bubble is labeled and vernier A is set at 0 degree. Then a backside is taken on A. The telescope is transited and by turning it clockwise, the ranging rod at C is bisected. Then the vernier readings are taken. Then the deflection angle phi 1 is determined. It is the average value of angles obtained from vernier A and vernier B. Similarly, the other deflection angles phi 2, phi 3 are measured. Then a field book is prepared in which the deflection angle and offset are clearly noted. Then the next method is fast needle method. This method is used to measure the magnetic bearing and length of traverse legs. However, the angles between the lines are not measured. Suppose A, B, C, D, A is a closed traverse. The following procedure is adopted. The theodolite is set up at A. The vernier A is set at 0 degree. The telescope is oriented along the north line with the help of trap compass or tubular compass fitted to the theodolite. The lower clamp is fixed. The upper clamp is loosened and the ranging rod at B is bisected. The reading on vernier A gives the fore bearing of AB. Say it is 30 degree. Then the back bearing of line DA is also measured from A. Now the upper clamp is also fixed. The traverse is considered in a clockwise direction. Then the instrument is shifted and set up at B with vernier A fixed at 0 degree at 30 degree. Then the lower clamp is loosened and the ranging rod at A is bisected. The telescope is now transited. The upper clamp is then released and the ranging rod at C is bisected. Now the reading on vernier A gives the bearing of BC. Say it is 100 degree. Again the instrument is shifted and set up at C with vernier A fixed at 100 degree. The same process is repeated to get the fore bearing of CD. Similarly, the fore bearing of remaining sides are measured. At the end of traverse, the fore bearing and back bearing of DA should differ by 180 degree. So in this slide we are going to see what are the checks to be applied when you consider the closed traverse. The sum of measured interior angles should be equal to 2n minus 4 into 90 degree, and the sum of measured exterior angles should be equal to 2n plus 4 into 90 degree, where n is the number of sides. Then the algebraic sum of deflection angle should be equal to 360 degree, considering right hand deflection to be positive and left hand deflection to be negative. Then the next check is the fore bearing and back bearing of finishing line should differ by 180 degree, so that we can say that the given line is free from local attraction. Then next check is the chaining of each line should be done twice along opposite direction, so that it is possible to measure the distance very accurately. Then check after computation. The sum of northing should be equal to that of the southing, and sum of easting should be equal to that of westing. In this slide we are going to see what are the checks in open traverse. In open traverse, measurements cannot be checked in the field. However, some field measurements are taken in order to ensure accuracy and determine the errors after plotting. The following are the field measurements taken for such check. So this is a figure which is going to indicate the tie line or cutoff line. Suppose A, B, C, D, E, F is an open traverse. Please refer the figure 9.19 below. The cutoff lines AD and DF are suitably taken. Then the fore bearing and back bearing of line AD and DF are measured. Also the distances AD and DF are also measured. After that, if after plotting the traverse, the distances and fore bearing and back bearing of cutoff lines tally with the field measurement, then the traverse is said to be correct. Then the next check is auxiliary point. An auxiliary point P is suitably selected on one side of the traverse. Then magnetic bearing of this point are taken from A, D and F. If the traverse and plotting have been done accurately, then all these bearings must meet at P when plotted from the stations. The traverse can also be checked by calculating the coordinate of the point P, considering ADP and DFP as closed figures. If the coordinate of P calculated from both sides are equal, then the traverse may be assumed to be correct. Then in this slide we are going to see what are the sources of error in theodolite. First is instrumental error. The following are the major causes of instrumental error. First is non-adjustment of plate bubble. In this type, the axis of plate bubble may not be perpendicular to the vertical axis. So when the plate levels are centered, the vertical axis may not be truly vertical. In such a case, the horizontal circle would be inclined and the angles will be measured in an inclined plane. This would cause an error in the angle measured. This error may be eliminated by leveling the instrument with reference to the altitude bubble also. Then the second source of error is line of collimation not being perpendicular to the horizontal axis. In this case, a cone is formed when the telescope is revolved in the vertical plane, and this causes an error in the observation. This error is eliminated by reading the angle from both faces and taking the average of the readings. Then sources of error. The third source of error is horizontal axis not being perpendicular to the vertical axis. If the horizontal axis is not perpendicular to the vertical axis, there is an angular error. This is eliminated by reading the angle from both faces, that is from face left and face right. Similarly, another source of error is line of collimation not being parallel to axis of telescope. In this, if the line of collimation is not parallel to the axis of telescope, there is an error in the observed vertical angle. This error is eliminated by taking reading from both faces. Similarly, another source of error is eccentricity of inner and outer axis. This condition causes an error in vernier reading. This error is eliminated by taking readings from both verniers and considering the average of the readings, that is face left and face right. Similarly, next type of source is graduation not being uniform. This is the error due to this condition that it is eliminated by measuring the angle several times on different part of the circle. Then the next error is vernier being eccentric. The zones of vernier should be diametrically opposite to each other when vernier A is set at 0 degree and vernier B should be set at 180 degree. But in some cases, this condition may not exist. This error is eliminated by reading both verniers and taking the average. Then the next type of source is personal error. The personal error consists of the centering may not be done perfectly due to carelessness. Second personal error is the leveling may not be done carefully according to usual procedure. Similarly, next personal error is if the clamp screws are not properly fixed, the instrument may slip. Similarly, the next error is the proper tangent screw may not be operated by mistake. Other personal error is the focusing in order to avoid parallax may not be perfectly done. Then next is the object or ranging rod may not be bisected accurately. Similarly, the verniers may not be set in proper place. It can be a personal error. Similarly, errors would also result if the verniers are not read because of oversight. In this slide, we are going to see the natural errors. The natural errors are because of high temperature causes error due to irregular refraction. Also, high winds cause vibration in the instrument and this may lead to wrong reading on the vernier. Then we are going to see what is the closing error and its limitation. In a closed traverse, the algebraic sum of latitude must be equal to 0 and so the algebraic sum of departure must be equal to 0. But due to errors in the field measurement of angles and length, sometimes the finishing point may not coincide with the starting point of a closed traverse. Therefore, the distance by which a traverse fails to close is known as closing error or error of closure, which is shown in the figure 9.2, where the distance between A to A1 is the closing error. So in figure, the traverse ABCDE fails to close by a distance AA1, which is the closing error of this traverse. Then the next check is auxiliary point. An auxiliary point P is suitably selected on one side of the traverse. Then magnetic bearing of this point are taken from A, D and F. If the traverse and plotting have been done accurately, then all these bearings must meet at P when plotted from the stations. The traverse can also be checked by calculating the coordinate of the point P, considering ADP and DFP as closed figures. If the coordinate of P calculated from both sides are equal, then the traverse may be assumed to be correct. So in this slide we are going to see the permissible closing error. So depending upon the traverse for land roads and railway survey, city survey, important boundary work, very important survey. Depend upon the nature of traverse to be conducted, we can have the permissible errors. So for example, the traverse for land, roads and railways to be carried out, then in that particular case the permissible error should be 1 minute into root n, or the permissible relative closing error should be in 1 in 3000. Similarly, for when we are going to conduct the traverse for city survey or important boundary survey, then in that particular case the permissible angular error should be equal to 30 seconds multiplied by root n, and in that particular case permissible relative closing error should be 1 in 5000. Similarly, the traverse for very important survey, the permissible angular error should be equal to 15 seconds multiplied by root n, and the permissible relative closing error should be 1 in 10,000, where n represents number of sides of a traverse. So in this slide we are going to see the computation of latitude and departure. In the Theta traverse survey, it is not plotted according to interior angles or bearing. So it is plotted by computing the latitude and departure of the points, and latitude and departure of the points is nothing but they are the consecutive coordinates, and then finding the independent coordinate of the points. The latitude of a line is the distance measured parallel to north-south line, and departure of a line is measured parallel to east-west line. So in the figure 9.21 you will find that there is a line AB. It is going to make an angle theta with the north, and here at angle B there is a theta. They are opposite angles, therefore they are equal. So by knowing the length of line AB, that is L, we can calculate by applying the trigonometry, we can calculate the latitude. So latitude is nothing but it is a distance measured parallel to north-south. Therefore by making angle theta and the length of line AB L, we can calculate the latitude as L cos theta and departure equal to L sin theta. So generally the latitude and departure in the first quadrant, they are positive. That is to say that if the line is lying in the first quadrant, the latitude is positive and departure is also positive. Similarly, if the line is lying in the second quadrant, then the latitude is negative and the departure is positive. Similarly, if the line is lying in the third quadrant, then both the latitude and departure, they are negative. Whereas if the line is lying in the fourth quadrant, then the latitude is positive and departure is negative, which is shown in the figure. Then we are going to consider the latitude and departure. They are expressed in the form of northing, southing, easting and westing. Then we can say that northing is a latitude towards north and it is always positive. Similarly, southing is also latitude, it is measured towards south and it is always considered negative latitude. Similarly, when you consider easting, so easting is a departure measured towards east, therefore it is always positive, whereas westing is also departure and measured towards west and it is always considered negative. The Theta traverse is not plotted according to interior angles or bearing. It is plotted by computing the latitude and departure of the points, that is consecutive coordinates, and then finding the independent coordinate of the points. The latitude of the line is the distance measured parallel to north-south line, and the departure of line is measured parallel to east-west line. But whenever you are considering the latitude or departure, so theta is the reduced bearing of line AB. So whenever you are going to calculate the latitude and departure, you must consider the reduced bearing of a line. So therefore, whenever we are having the values of whole circle bearing of a line, then we have to convert the given WCB to reduced bearing depending upon the line in which quadrant in which that particular line lies. For example, if the WCB is in between 0 to 90 degree, then reduced bearing equal to whole circle bearing, and therefore that particular line lies in the northeast quadrant. Similarly, if the whole circle bearing is having a range of 90 degree to 180 degree, then in that particular case reduced bearing is calculated as 180 degree minus whole circle bearing. So for that line, the line is lying in the southeast quadrant. Similarly, if the line is lying in the third quadrant, that is southwest quadrant, then the reduced bearing is calculated as WCB minus 180 degree. Similarly, if the line is lying in the fourth quadrant, that is the WCB having value 270 to 360 degree, then reduced bearing equal to 360 degree minus WCB. So that particular line lies in the northwest quadrant. Refer the table 9.6 for computing the latitude and departure, where there is a closed traverse and the lines are AB, BC, CD and DA, and the lengths are L. So in that particular case, the first line is lying in the first quadrant, that is N theta E. Similarly, second line is lying in the second quadrant, that is S theta E, and the third line CD is having a reduced bearing of S theta W, and last line is DA, and it is lying in the fourth quadrant, that is N theta W. Therefore, whenever we are going to calculate latitude and departure, so the latitude and departure in the first quadrant, they are positive. Therefore, latitude is equal to plus L cos theta and departure equal to L sin theta. Similarly, if the line is lying in the second quadrant, then latitude is negative. Therefore, it is minus L cos theta and departure is positive, and the departure value is plus L sin theta. Similarly, if the line is lying in the third quadrant, then the latitude and departure, they are negative, therefore they are minus L cos theta and minus L sin theta. Similarly, if the line is lying in the fourth quadrant, then latitude is plus and departure is minus, that is plus L cos theta and minus L sin theta. Similarly, whenever we are going to consider the check for closed traverse, the algebraic sum of latitude must be equal to 0. Similarly, the algebraic sum of departure must be equal to 0. So, please refer the table 9.7, in which line, length, reduced bearing and consecutive coordinates are written. So whenever we are having the value positive, they are to be entered in the northing or easting, and whenever we are having the value of latitude, they are to be entered in the negative, that is southing column. Similarly, for departure, they should be entered in westing column. So consider the line AB. It has got L cos theta, therefore it should be entered in the northing column. Similarly, consider the departure of AB, so it is plus L sin theta, therefore it should be entered in the easting column. Then consider the next line BC. It has got latitude of minus L cos theta. Since the latitude is measured towards south, it is negative, therefore it should be entered in the southing column. And the next departure is plus L sin theta. Since it is plus, it is measured towards east, therefore it is entered in the easting column. Likewise, for CD and DA, the consecutive coordinates are entered, and then sum of northing must be equal to sum of southing. Similarly, sum of easting must be equal to sum of westing has to be seen, and this is the check for closed traverse. Thank you, friends.